Hello, everyone. Thanks for joining this episode, Tech Interview Made Easy by Dr. Ho. Today, we're going to talk about an interview question asked by Microsoft. Is Seattle actually raining? So the question is like this. You have three friends in Seattle. Each of them told you that Seattle is raining. But you know that the probability of them telling you a lie is 1/3. So what's the probability of Seattle that's actually raining, assuming that the likelihood of rain in Seattle on any given day is 0.25. Before we jump into any of the solutions, let's first simplify this question into math terms. So let's see what we have here. So we have that the probability of rain on any given day is 0.25, which is 1/4. And we also know that the probability of your friends telling a lie is 1/3. So the probability of your friend lying to you is 1/3. So the question is, what is the probability of raining in Seattle, given that all your friends telling you that it is, right? So the probability of Seattle is raining, given that all your friends is telling you yes. So right, 3 yeses. This is a very standard conditional probability, right? Given all your friends said yes, what is the probability that Seattle is raining? So let's first review some of the basics of conditional probability here. So let's have some short review of conditional probability. So the formula for conditional probability is that we have two events A and B. So what's the probability of A given the event B happens? So the formula is the probability of A intersect with B divided by the probability of B, right? And then we can rewrite this as the probability of A intersects B, which means A and B both happened, equals the probability of A given B times the probability of B. Similarly, if we have the event A happened, we want to know, given that A happened, what's the probability of B? So we have the same similar formula. So we have probability of B intersect with A divided by the probability of A. And we can rewrite it as probability of B intersect with A equals the probability of B given A times the probability of A. Notice that the probability of A intersect with B is the same as the probability of B intersect with A. So we can combine these two equations to this third one here. So that gives us the probability of A given B times the probability of B equals the probability of B given A times the probability of A, right? Because they both equal the probability of A intersects with B, means A and B both happened. So once we have this, then we will rewrite it as the probability of A given B equals the probability of B given A times the probability of A divided by the probability of B. This is the final formula we're going to use to solve this interview question asked by Microsoft. Now we can move on to solve the actual question. So let's associate this formula with what the question is asking. So in this question, we can define the event A to be Seattle is raining. And then the event B to be your friends, right? So all your friends said yes. All friends said yes. Now let's plug into the numbers into the formulas here. So basically we have the probability of A, which is the probability of Seattle it's actually raining, is 1/4. And then we also have the probability of B given A, which means when Seattle is raining and all your friends are telling you Seattle is raining, so they're actually telling you the truth. So that means it's 1 minus the probability of lie to the third power, right? So all of them are telling you the truth. So let's plug into the numbers. So that's 1 minus 1 over 3 to the third power, which is 2/3 over to the third power. Sorry, I have to type this on the computer. To the third power, so that's 8 over 27. The last part is the probability of B. The probability of B is a little tricky, so let's break it down here. So what does it mean by the probability of all your friends said yes? Okay, so it has two cases. The probability of your friend said yes, given that the Seattle is raining, right? So we have the case when Seattle is raining, and given that case, all your friend said yes. Or we have another case, right? Given the Seattle is not raining, and all your friends said yes, right? So when we are in a situation when Seattle is not raining, and given that what your friend saying to you are all yeses. So those are the two cases that we need to compute the probability of B. And then now let's plug into the numbers here. So the probability of B given A we already computed in the above equations. So that's 8 over 27. And then that's in a case when Seattle is actually raining. And we know that the probability of that Seattle is raining is 1/4. So that's the first case. And the second case is that when Seattle is not raining and all your friends are telling you that it is. So they're actually telling you the lie, right? So that the probability of your friend lying to you is 1/3. And then all of them are lying to you, that's 1/3 to the third power. So let me type that here. And then that's in the case when Seattle is not raining. And then when Seattle is not raining, that's just 1 minus 1/4. And then if we add all this together, so that's 8 over 108 plus 3 over 108. So that's 11 over 108. So now we have the probability of all these three terms, then we can finally compute the probability of A given B, which means given that all your friends telling you that Seattle is actually raining, how likely that Seattle is actually raining. Okay, so that's plugging into the formula. So that's the probability of B given A times the probability of A divided by the probability of B. So we have all the numbers above. So that's we have 1/4, or we have 8 over 7. So we have 8 over 27 times 1/4 divided by the probability of B, which is 11 over 108. So that's 8 over 108 on the top, 8 over 108 divided by the denominator is 11 over 108, and then that simplifies to 8 over 11. So yeah, so that's the final answer. Let me circle that. So that's right. So we have the probability of Seattle it's raining given all your friends are telling you that Seattle is raining is 8 over 11. Thanks for watching. If you enjoyed this video, give it a like and subscribe. I'll see you in the next video. Thank you.